Okay, and now we will discuss one more past paper together. Okay, this past paper is given to you yesterday as well, so please take it out. Okay. Oh, I hope you have tried doing it. Okay, but if you haven't, would you please switch off this video? Try do it before you watch it. Okay. Ethanoic acid is formed as vinegar by the bacterial oxidation of ethanol present in wine and other solutions. There is an equation. Okay, we just learned this is oxidation of ethanol, right? So what oxidizing agent? Now what? What? The question doesn't restrict you to name it, so you can basically put down acidified dichromate solution. It will be fine, okay? Unless the question asks you to name it, then you have to come up with acidified potassium dichromate solution. I put it here. Okay, acidified dichromate solution. What color change? Of course, we know that when the ethanol is oxidized, right? Oxidized, and then the dichromate ion will be reduced to chromium, right? This reaction happens simultaneously. This is a redox reaction. So originally the dichromate color is orange, and it is reduced to green chromium 3 ion, right? Okay, any question? If no, then I move on. When ethanoic acid is prepared in this way in the laboratory, the reagents are heated under reflux for some time before the ethanoic acid is separated. Why is the reaction carried out by heating under reflux? By heating under reflux, first, we don't want to lose any reactants, right? We don't want to lose any reactants. We want to keep all the reactants in the reaction mixture. Second one is we want to make sure the oxidation is complete, right? Because you know that the ethanol is first oxidized to ethanol, and the ethanol will go to ethanoic acid, right? So by using heating under reflux, you can basically make sure all the ethanol as the intermediate will go to ethanoic acid before you stop the reaction. Okay, now there are two, even though the question just needs you to put down one. You can say to keep all the reactants in the reaction mixture. Okay, like in the exam, do not write outside this margin. Okay, any things that are put outside this margin will not be marked. Okay, but right now I don't have enough space, so that's why. And I have to come up with 2 points, right? You just have to come up with 1 point in the exam, so you can put your answer. You can continue with your answer on the second line. Okay, and then to make sure the oxidation of ethanol is complete. Okay, this is very important. Complete. Okay. 好, what would be the main organic compound formed if instead of heating under reflux, the reagents were heated together and the products immediately distilled off? I told you already, immediately distill off. If now first ethanol, right? It will go to ethanol. Ethanol. And then we'll go to ethanoic acid, right? If you want to get this one, you will set up your you will have your experimental setup of distillation to get it, right? But if you want to go all the way to get this one, you will be using heating under reflux. Okay, this is what I told you before, right? If you want to get this intermediate, you start your setup with distillation, okay? Do not use the heating under reflux setup. But if you aim for obtaining the ethanoic acid, then you use heating under reflux, and then the ethanol will go all the way to ethanoic acid, then you can get ethanoic acid at the end, okay? So right now the question asks you, if you try to immediately distill the reaction mixture, then what will you get? Of course, that will be ethanol, because yeah, you start with ethanol, right? So ethanol, okay, that is aldehyde. Okay, 好， The third one, if phenolic acid is manufactured from methanol by reacting with carbon monoxide in the presence of catalyst, okay. So one stage in this is the reaction methanol. Methanol with hydrogen iodide. We learned this reaction already, huh? Do you remember? So if you still remember this reaction, this is nucleophilic substitution reaction. These two groups will be switched, okay? So what organic compound? Still, not name, so you don't have to come up with a name. This will be like that, okay? The two functional groups, they switch, okay? Okay, a later stage involved the conversion of intermediate compound. Okay, what type of reaction? Okay, now obviously this is positive, okay? Because this is negative and this is negative. So I bet the OH minus. Now, even though we haven't studied exactly this particular reaction, but according to what we have learned, you should be able to predict what's going on here, right? So basically, this lone pair will attack this positive carbon, and this bond will be broken, leading you to obtain this product. So what type of reaction is this? Substitution, or to be more concise, nucleophilic substitution reaction. Okay? Any question? If not, then we continue. Okay, these can you see we came across a very similar question in the previous past paper. So the question is actually very repetitive. Okay, so always ask you to give the reagents and then the conditions and then the observation and then Port is responsible for the observation. So you have to recite all the chemical reactions, every single one we learned before. Okay, so step one, this one, okay. But you can copy, can you see that? Can you see that? You can copy. Can you? OH, okay, and then hydrogen halide will become this one. So the reagent will be HI, right? And then heat, right? You can copy. Of course, we can use a lot. We can use PI3, PI5, okay? This is heat, right? Okay, stage 2. This one with this one, we learned this already. We can use NaCN in ethanol, the solvent. Step 3, this one and this one easy, hydrolysis of a nitrile group. So you just need come up with a mineral acid. Don't just write down H+. For example, HCl, and then heat again, or reflux. Okay, reflux. Okay, that's the end of this question. Okay, now once again, if you haven't finished this past paper, I highly suggest you to attempt the questions first before you watch this video. Okay, do not waste the question. I will give you more questions in SATA, okay, later. Then I will discuss the questions with you after giving you a period of time to attempt the questions, okay? Keep going, do not give up.